Welcome to AP Calculus BC. We are on lesson 2-5 today, derivatives of polar functions. You guys want the TLDR? You want the too long didn't read? I can summarize these notes in maybe two sentences.
Yeah. Go for it.
So, first sentence, convert to parametric, then use parametric formula that you learned yesterday. The end. All right, so let's go ahead and say that today's date is Tuesday, March 10th, 2020. We are indeed doing derivative of polar functions. It's our last lesson in Unit 2, and then when we get back from Ski PE on Thursday, we have self-checks.
No.
Self-check, and then on Monday we get back and we do a pre-test, probably a pre-test. Yeah. All right, so there's a lot of things that we're doing. The objective is pretty straightforward, James. It is to...
Find the derivative.
You got this.
Find the derivative of polar functions.
There it is. It's almost exactly what the title is, so it's not that impressive. He said shoot. All right, so Mr. Sindel said shoot. I know. If I have a function, I'll call this function 1, the function 2. Someone tell me the product rule. Quiet raised hand. Who knows product rule? Who knows this? Who has a quiet raised hand that I can call on? Please, someone. Arrows are back up. I know she'll know. Theoretically, yeah, Andrea. 1d2 plus 2d1. You will need this guy over and over today because they being the people that make the AP test, like to use product rule in their questions. And I know I put a few product rules in last night's homework. I'm going to be putting in the product rule in all of the homework tonight. Evil laugh. All right, so first of all, let's remember what the derivative of a parametric function is. In order to get dy dx, what do I do? Remember, parametric is in terms of t, so you have to do dy dt and stuff with that. Do you guys remember the formula? No? No one remembers the formula? That's not good. No one remembers the formula? Look back at your notes. I'm not going to do it. You guys do it. I'm going to be stubborn here. Look at your 2-4 notes. What is dy dx in terms of dy dt and dx dt? No one's looking at your notes?
I was looking.
So dy over dx is equal to?
I don't know.
You said it incorrectly. That's why I wasn't going to go for it. There it is. dy dt in the numerator, and then dx dt in the denominator. Essentially, it boils down to this. The top of the fraction is the derivative of y. The bottom of the fraction is the derivative of x. The end. James.
Isn't that supposed to be dx?
It is. Thank you, log it. I don't know why I keep doing that.
It goes to the person across.
Yeah, that's how it works. Anyway, so we know the derivative of a parametric formula. Let's go ahead and find the derivative of that polar function. Why is it polar? Well, I have an r is equal to something with theta in it. Therefore, we are polar. So the first step, convert it to a parametric form. Do you guys remember how to do that? All the way back from Unit 1. We say x is equal to blank, y is equal to blank. Fiona, do you know it? Arrow, do you know this? No? Oh man. We really...
What was the question again?
How do I convert a polar equation into a parametric equation? It is times cosine, and then y is times, there it is. So everyone rewrite 2 plus 3 cosine of theta for both of these. Here, even more generally, I'll give you the formula. This is the formula that you have to have memorized. It's r times cosine of theta. Y is equal to r times sine of theta. Where's r? R is right there. We're going to rewrite that twice. This is r, and that's going to go into this r right there and this r right here. So I come down here and I say this x is really equal to 2 plus 3 cosine of theta, and all of that times cosine of theta, because that's the definition. And then y is equal to 2 plus 3 cosine of theta, and then all of that in square brackets or extra set of parentheses times sine of theta, not cosine of theta anymore. Sine of theta. Done. That's as easy as it gets. We have converted into parametric form. One of them is times cosine, one of them is times sine. And then we're doing this formula now. I have a y and I have an x. I'm going to take the derivative of y with respect to t on the top, derivative of x with respect to t on the bottom, and I'm done. We've solved it. I'm trying to make this as simple as I can for you guys. So I'm taking the derivative of this one on the top, derivative of this one on the bottom. So it's going to be product rule. I'm giving you that warning. It's a product rule because I have one function times another function. I have one function times another function. So it's going to be product rule on the top and the bottom. We can all write it down. dy dx is equal to, all right, we're taking dy dt for the top. Dy, let's write out dy dt for the top, and dx dt for the bottom, which is equal to, all right, who wants to attempt product rule for that y function? I believe in you guys. I'll help you through it too. You get Mr. Sandell's assistance. All right, G, I'm putting you on the spot. I'll help you out. 1d2, so what's 1? 2 plus...
Sine. Wait.
This is all of 2, right? Or this is all of 1.
That's all.
That's all of 1, yeah. So 2 plus 3...
Cosine of
Okay, that's 1 times...
Cosine of theta.
Careful.
Which one is 2?
So this is 1, this is 2.
Okay, that's cosine of theta.
Careful.
It's still the same, right?
Oh, it is cosine of theta.
Bro, what you
Don't be careful. You got it. Good job, Gio.
You tripping?
And then plus...
3 negative sine of theta.
Are you doing 2d1 right now?
Wait, hold on. Oh, wait. What am I doing? I'm doing. Oh, okay. Hold on. Sine theta.
Sine of theta. Keep going.
So it's 3 negative sine of theta.
Yep, negative 3 sine theta. There it is. Gio has the numerator done.
Wait, can I get the extra point?
Yeah, log it.
I don't have extra point.
Oh no. That's not good. If you have it for AP calculus, you can log it there.
Well, I'll log it later.
All right. Then the denominator. Who's going to try product rule again? Product rule. It's doing the same thing again. Eva, go for it. 1d2. Here's your 1. Here's your 2. So 1d2. There's your 1. D2. Negative sine of theta. Perfect. So you have 1d2 plus... That was our 2 times... It's the same thing, yeah. Negative 3 sine of theta. Done. Ta-da! We have our answer.
That's it.
We could simplify this thing, but there's not... I mean, there is a point me telling you to practice simplifying, but these guys are so gross and disgusting like 90% of the time that you're going to have a lot of different forms here. What could we do in the top? We could factor out a... nothing. What could we do on the bottom? We could factor out a sine, but that's about it. You can't really do that much. So the one thing I want you to take away is these guys are gross. That's pretty easy to take away. Look at that. That was hard, right? The second thing that I'll take away is the process is really easy as long as you remember how to take the derivative of a parametric equation, which is just you take the derivative of the y divided by the derivative of the x. That's the answer. I could simplify that just a tiny bit, but I'm going to leave it like that. So if you need a tattoo, that thing looks pretty cool, right? It makes you look smart. All right.
So what is it? That's like, where's the difference? Oh, I don't know.
All right, let's try I'm going to do one more example on the back, but I want to talk to you about the general formula that is listed in textbooks, which I'm not going to make you memorize. Do not memorize this unless you have nothing to do. You're like, I'm just going to twiddle my thumbs for an hour, or I could memorize the definition of a polar derivative. So here you go. First, you're going to convert to a parametric form. So if I have a general function, let's just say I have r. I have a general function r, and it's equal to something. It could be the same function that I had up here, but some function. I don't know what it is, but generally I have r. So if I convert to a parametric, the generalized way of converting to a parametric is x is equal to r times what? With a quiet raised hand. In terms of converting this r into a parametric form instead of polar form, what do I multiply r by to get x? Same thing for physics, same thing for pre-calculus, same thing for all of our classes. In order to get x, is it cosine or is it sine? Quiet raised hand. Is it cosine or sine? Yes, Andrea. It's cosine, so I'm going to multiply by cosine of theta. In order to get the y, and I guess I can put these down here. I don't know why I'm putting them off to the side. I don't have enough room over there. If you can squeeze them in, that's perfect. And then if I want the y is equal to what? Yes, Chris.
Sine.
Yep, r times sine of theta. Thank you. Sine always pairs with y. Cosine always pairs with x. You can thank whoever gave you help. I heard whispering. But you could have gotten it on your own without help, right?
You're tripping.
Tripping. Okay, I may be going insane hearing voices in my head. Take the derivative of x and y. So if I take the derivative of that thing, I have two things that are being multiplied together. I have 1 and 2. I have 1 and 2. So I'm going to do 1d2 plus 2d1. So I'm going to say down here dx dt is equal to, well, it's 1d2, right? So 1 is r, and then d2 is, the derivative of cosine is negative sine. So r times negative sine of theta. And then plus 2d1. So plus 2, which is cosine of theta, d1, r prime, times r prime. Woohoo! We found the derivative of x. Someone else do the derivative of y. Get some more participation in here.
R.
dy dt, go for it, Gio. 1
Times cosine.
d2, good, keep going.
Sine. Negative sine, actually.
I think it's still sine because it's just 2, right? You just rewrite 2.
Oh.
And then d1,
E. R prime.
r prime. There it is. So Gio found our dy dt, and then you just plug this into your parametric equation. Our derivative of a parametric, by definition, I'm writing it like for the third time now, so hopefully it's really making sense. Dy dx, the thing that we're always trying to find, is equal to our blue dx dt, all of that divided by our yellow, or orange, whatever this color is, dy. Wait a sec. Okay, who wants to catch it? Stego. Yeah, I don't know why I'm writing dx dt. Our orange dy dt divided by the blue dx dt. I guess I need to write it a few more times too if I haven't memorized it yet. And then we just kind of rewrite these things. So I'm going to write it a little bit neater instead of copy pasting it. So our dy dt, all I'm going to do is I'm going to put that r prime in front of the sign, and that's all I'm going to change. So if I'm rewriting this is going to be r cosine of theta plus r prime sine of theta. And then in the denominator we have basically the same thing, negative r sine of theta plus r prime cosine of theta. And this is the formula that people tend to use in textbooks, like I said, but I'm not going to make you memorize it because every single time on the AP test that I've seen in the limited 6 problems I've done between yesterday and today, everything can be done by doing just parametric. Just remember one formula instead of 2. Always convert to parametric, then take the derivative. If you want to memorize this and save maybe, I don't know, 10 seconds, I don't know how much time you'd actually save, then that's cool, but yeah, just memorize one formula. And I'll even type that here. Don't memorize this. don't memorize this. Just remember the derivative of a parametric function. All right, I have one more example, and then we're done. Let's see if you guys can do it on your own. I want you guys to try example number 2, and I want you guys to work, or at least check your work, with one other person. And you guys can totally work together in a group of 2, a group of 9. I don't really matter, or I don't care either way. So this is the general setup. We have our X and our Y. We have those set up. The most common mistake that I see people making on this, and I have never seen this, so it's not past tense, but I'm going to guess most people are going to forget this 4.
4. Oh, 4.
This is the dinner
Yo, I
ender.
don't know what you're talking
Yeah,
about.
what 4?
All right, so,
No, look. The screen's not working.
oh, that's what you mean. Aha.
Yeah, there you go.
So, no.
What? It's a teacher mistake, though.
Fine, log it.
Oh. What?
All right, so
Why did you get it?
this is 1 times D2 plus 2 times this right here should be D1. The derivative of this one right here, well, the derivative of 5 is nothing, so that went away. The derivative of sine is cosine, so I wrote down cosine of that 4 theta. But I also have to take the derivative, I guess it's not really the dinner inner, it's just the dinner. Multiply by the dinner. The dinner is 4. The derivative of 4 theta is 4. So that would be the common mistake. And I'm going to keep finishing this problem, sure, on video, why not? Now, this is going to be 1, which is going to be 5 plus sine of 4 theta. 1, that yellow 1 right here, D2 times the derivative of this is going to be positive cosine of theta, plus 2, which is sine of theta, times the derivative of this one, and again it's going to have a dinner to worry about. So the derivative of it is going to be the same exact thing as cosine 4 theta times 4, times cosine of 4 theta times 4. And then I have to simplify just a little bit in my fraction. Essentially I'm just rewriting all this stuff. It's going to be the yellow that goes on top. And there's not much that I can do aside from putting that 4 in front. So using technology, is there a question?
No.
It's that same thing right here. I can probably put the 4 out front. I can bring that 4 right there. Let me move this stuff over. Move that 4 right there. And do the same thing with the blue. Grab all of that. Copy paste. And very similarly, I'm going to grab all of this, move it out, and put the 4 directly underneath. Shoink. Oh, and I realize that both of those dots don't need to be there anymore. Cool, and that's about as much as I could simplify it. I guess, no, I can't even do cosine squared because it's different insides right here. So
Am I sneezing?
I'll make a note here if anyone is paying attention. This does not equal 4 cosine squared of something, because these are different insides. All right, and that's the end of the note.